Okay, imagine you have to factor the ugliest polynomial you've ever seen. Well, the bridge for math is here, Dr. B, and we're going to talk about something that's pretty crazy, but it's going to help you out with this part of your algebra learning. Let's start off, I guess, maybe with the question. What if you are given a polynomial x to the fourth plus 2x cubed minus 17x squared minus 18x plus 72? Yes, that's a crazy polynomial to the fourth power, fourth degree polynomial. And what if we said, hey, we got to factor that? It's not a quadratic. The old days where factoring was pretty easy. Now we got a fourth degree polynomial. Well, there's a process to find zeros. And once you find zeros, you can find factors. And that's how you can actually solve this. So if you've been watching the other videos, I talk about what zeros are. Let's just give you a quick reminder. Zero is an x value that when I plug it into this polynomial, it adds up to the quantity of 0. Well, if you're on an island, you would be trying everything on the number line. It could be literally anything. It could be any rational number. Well, fortunately, there is this theorem called the Rational Zero Theorem. Word rational makes you think of fractions, right? Well, the Rational Zero Theorem essentially is the first board that I set up for you. Here's an abbreviated definition. You have this polynomial. You have this biggest power in front. We're making it descending order, biggest to smallest, descending order for polynomials. Notice the things that usually confuse students are the subscripts. This is a subscript n to represent this is the biggest exponent would be your n. Then you go drop a power, n minus 1. So descending order. Well, they use this coefficient a subscript n minus 1 to represent the number in front of that decreased power. This dot 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 basically says pattern continues. And it goes down to a2 x squared, a1 x to the 1, a0. And you could literally have x to the 0 power, but anything raised to the 0 power is 1. But let's look at this. Don't get lost in this. Pretty simple. If we want to find these x values that are called zeros, all you have to do is find this coefficient, this last coefficient, a0. We want to find the factors of a0. The factors of a0, we actually call them p-values. Then you find the first, the lead coefficient. We find that, that's an. You factor an. We call those numbers q. And essentially, you divide p divided by q. Those are the possible zeros. So let's kind of see this in action. But I want you to understand the possible zeros are p divided by q. And there's a whole bunch of p over q's. And they're not all going to be zeros, but they kind of guide you to where you should start looking. So let's go back to that question. The question said, factor or find the zeros of this polynomial. Well, we start off, what's my a0? That's 72. What is p? Would be the factors of this 72. What are the factors of 72? Well, there's a lot. Notice I put plus or minus. That means it's a positive one or a negative one. They divide evenly into 72. 2 or negative 2 divides into 72. Turns out you have 24 factors that could be your p-value. And you might be going, that's a ton of work. It's too long. It's crazy. But I want you to understand, it's that or an infinite number. So you've actually narrowed it down to a small little area. Now the q values, again, the number in front, your lead coefficient an, your q are the factors of 1. Isn't that nice? Just 1 or negative 1. What we're going to do, we're going to find our possible zeros for the Rational Zero Theorem, just dividing every p by every q. So you want to be systematic, do 1 over 1, 1 over negative 1. You just keep taking every p divided by every q. Turns out it's going to give you 24 such possible zeros. What do you do next? Notice I said the word possible. It doesn't mean that it is a zero. It's possible. How do we find out if it is? We do something called synthetic division, where all these p over q's, we call them our possible c values. If you study synthetic division, the c value is what you put into the synthetic division. Well, what's the first 1 over 1, the p over q? How about 1? Remember synthetic division? How did we get these numbers here in this upside down looking division sign? Well, we got them as the coefficients of this polynomial. The 1, 2, negative 17, negative 18, 72. And if you remember, bring down this first one every time below the line. You take this c value out here, the p over q that you found, and multiply it. You go 1 times 1 gives you 1. Bring it up. Follow the arrows. I give you these arrows to see the pattern. Then you add the 2 plus 1 and see the arrow gives you a 3. Continue this process. 1 times 3, bring it back up the line, is 3. Negative 17 plus 3 gives you the negative 14. It's below the line. What do we do? Yeah, you multiply it by the 1. What's 1 times the negative 14? Bring it back up, it's negative 14. What's negative 18 plus negative 14? Do the math, negative 32. Below the line, what do we do? Yes, multiply it by the c value again. 1 times negative 32 gives you a negative 32. You add it to the 72, and check this out. It adds up to 40. Now this last number is the only number you care about. Some of my best students go, what if I would have found a value of 0 over here? It doesn't matter over there. It's that last number called the remainder in synthetic division that you care about. Since 40 is not equal to the value 0, x equals 1 is not a 0. Now, you have to do this as many times until you find the zeros. So I will tell you, you have to be patient. So I'm going to be jumping. I'm going to say, well, let's try 3. I mean, obviously you could have gone to negative 1 and then 2 and negative 2, but I want to show you something and I want to keep this video somewhat short. So I'm going to jump to 3. Do you agree 3 was the p over q? Because you have a p value of 3 and you have a q value of 1, p over q would be 3. So this is a possible 0. Do the same synthetic division and guess what happens? This last number, the remainder in synthetic division, is 0. So guess what that means? You have found a 0. X equals 3 is a 0. And x minus c, which is part of your synthetic division, x minus 3 is a factor. There's your first factor of that 4th degree polynomial. Good job. Well, let's try negative 3. Because I actually did work this problem out before I started here. It does turn into a 0 doing the same thing. Notice I'm not showing you all the work. You can watch the video and go back to see how it works. You get 0 again. Notice I used the same coefficients. So now we have 3 and negative 3 are zeros. Well, you might ask yourself, how far, how long do I check? How do I know if I've found all my zeros? There's something called Descartes' rule that you can look up in probably some future videos. Or if you notice, it's a 4th degree polynomial. If you have a 4th degree polynomial, the fundamental theorem of algebra says that you will only have, at most, 4 zeros. So we know we're getting close. I wanted to show a shortcut that some of the people who get really insightful see. Do you see the numbers when you first found that remainder of 0 in synthetic division? Do you see the numbers below the line? You actually could use those numbers to do your next synthetic division. It speeds things up. So I brought these numbers down and I tried negative 3 again, just to show you that it would work. Sure enough, came to 0. Now, one thing I haven't said for synthetic division yet is, what do these coefficients represent? When we first started, what do you think the 1 represented? It was 1 times x to the 4th. What do you think 2 represented? 2 times x to the 3rd. So when you go below the line, you actually drop 1 power. So when we're here, we would 1 power and then we dropped another power to go below the line. So the 1, 2, and negative 8, you know what they represented? 1x squared plus 2x minus 8. That was another factor. Why does that speed things up? Well, can you factor a quadratic? Oh yeah, you know you can. What number multiplies to give you negative 8 and adds up to a positive 2? There's your positive 4, negative 2, x plus 4, x minus 2. That's the quick way to do some synthetic division. You might want to look at that and play with your synthetic division to see it. But let's look at the final answer. These are your factors. Turns out x minus 2, x minus 3, x plus 3, and x plus 4. If you multiply that out, does it sound troublesome? Yeah. But if you're patient and careful, you'll get the polynomial you started with. So that's how you factor such a beast. What zeros did we find? 2, 3, negative 3, and negative 4. 4 zeros. It worked out nicely. And you know, your teacher might give you tough questions like, well, tell me about the zeros. The way I would say that is, there's 4 zeros, 2 of them are positive, 2 of them are negative, and if you added them all up, you'd add up to negative 2. So good luck. There's a lot to chew on, but this is the bridge for math. My best, you keep trucking.